When schools use signal blocking bags as part of device management for student focus, the expectation is simple. Once a device goes in, Wi-Fi, cellular, and Bluetooth are cut off. Notifications stop and Bluetooth devices unpair. But there's a bigger, more important question. How long does that silence actually last? In schools, these bags aren't gently placed on shelves. They're opened, closed, stuffed into backpacks, dropped, spilled on, and handled hundreds of times per year. Longevity matters because a bag that blocks signals on day one but fails mid-semester is no longer doing its job. So we set out to test not just if these bags work, but how long they keep working under real-world use. So here's a control test. Every bag here, including CellLocked, Tech Protect Us, Faraday Defense NX3, the Faraday Defense Jacket Pro, and the Generation Faraday V2 Max Lock, they all claim to block signals. So the first thing we did was we verified that using the same test setup for each one. Each phone was placed inside of the bag, sealed, and checked for Wi-Fi, cellular, and Bluetooth at a controlled distance from the signal source. Right away, differences appear. Generation Faraday, Tech Protect Us, and Faraday Defense fully stop cellular and Wi-Fi signals. The CellLocked bags do not, right from the get-go. It's worth noting why. CellLocked bags, as claimed by the manufacturer, are designed primarily to reduce EMF exposure, not to fully block signals, and visually, their construction reflects that. The CellLocked bag has a single layer of Faraday material on the inside, and a magnetic opening without any redundancy to interrupt signal path. Bags constructed this way, which there are some others on the market, may not fully block signals. Now let's talk about cycle testing. In a school, these bags are handled constantly. They're opened and closed again and again, at least once a day, sometimes maybe up to 14 times a day. In order to test longevity with real-world use, we set up a controlled test where we cycled the phone in and out of the bags. We tested multiple bags of each type. For our testing, one cycle equals the bag opened, the phone placed inside, the bag closed, the bag opened again, phone removed, and then the bag closed again. This replicates a real-world usage scenario. We completed hundreds of cycles, and then thousands. Every 100 cycles, we checked the signal again with the same signal testing process. As the simulated use continued, signs of wear started to appear. This is where the construction and material quality of every one of these bags really matters. Once the interior Faraday is damaged, signal failure is immediate and irreversible. Some bags lose their ability to block signals quickly. This performance gap becomes easiest to see after time. 100 cycles only, 200 cycles, 300, all the way up to thousands of cycles. That difference isn't a few extra uses. It's months and years of real classroom use. But the cycle count alone doesn't tell the full story because schools don't operate in controlled environments. They operate in the real world. The outer material of the bag is what protects the Faraday from spills, handling, and student use. That's what we're going to test right now. We dunked each bag into dyed water for 1 minute. After this test, we cut open the bag to see how much water seeped through and damaged the Faraday on the inside. You can see that the TPU on the Generation Faraday Max Lock V2 outperformed the other foam, nylon, and fabric exteriors. Once water reaches the Faraday lining, the signal blocking integrity of the bag is ultimately compromised. A waterproof exterior prevents that failure chain. And now let's go ahead and start that test. So I'm gonna take each one of these bags and we're gonna test it by dunking it in our dyed water. We'll pull it out and then we'll cut it to see what the Faraday looks like on the inside. Now I'll move these aside so we don't get them wet and they stay dry for our test. And we'll start with the CellLocked bag. We're gonna place this bag in the water and then let's go ahead and remove it. We'll give it a cut down the side. And then we're going to examine the Faraday material on the inside. And what we'll notice is that the material is wet on the inside and the Faraday is wet itself. Furthermore, we only have one layer of Faraday on the inside, and this bag doesn't block signals in the first place. But it's worth noting that this material does leak through when placed in water. And we can see that here with moisture on the inside. So this bag fails in our moisture test. Next bag up, Tech Protect Us.
Yep.
We're gonna do the same test, dunk it in water here for about 30 seconds, and we'll remove the bag. And this appears to be a foam material inside of this one with a water resistant but not waterproof exterior, and we have stitching. So any water or moisture is gonna leak in through the stitching. And we'll go ahead and cut this upward to take a look at what happened. We'll open this and take a look that we have water that's come through the backside. It's penetrated the foam into the bag, and it's come through to the Faraday material on the inside. That's the Tech Protect Us bag, and it's failed under our moisture test. Next up is the Faraday Defense NX3. Now this bag appears to be made with Faraday fabric on the outside with no protection. We have sewn seams here, and there's no outer layer for protection here. So we'll place it in our water and see what happens. Now we'll remove the bag. Ooh, it looks like it's full of water. Yep. All right, that one leaked in quite a bit. Let's cut it to take a look at what happened on the inside. All right, we've got quite a bit of moisture in here that we can see. It's leaking out, came out the bottom. And we were right, there's no protective layers here. It appears that we have just Faraday material. And you can see on the inside, the Faraday material is soaked. We've got moisture lines right in there. So yep, this leaked completely and this bag failed according to our moisture test. Next up, we have another Faraday Defense bag, slightly different, magnetic closure. Let's go ahead and do the same test. Okay, we'll take the bag out. Let's do the same thing and cut it up, see what we find. Now this bag does appear to have some sort of moisture resistant barrier, but if we take a look down here and we see closely, we can see that the Faraday fabric itself has become wet and is compromised. And that's because this is a seam construction with sewing, and that enters in ultimately, and the moisture gets into the bag and compromises the Faraday fabric. Now for our final bag, let's take a look at the Generation Faraday MaxLock Pro V2. Now this bag is made with a TPU exterior. It is a fully waterproof construction. This is accomplished by way of seam welding, which makes an airtight seal, similar to a cooler that you might have at home or another waterproof bag that you might have seen that uses a construction like this. There's no seams in this, and this material is 100% waterproof. We're gonna dunk it, just like we did the other bags, and let's see what happens. Okay, we'll pull the bag out. Now we're gonna go ahead and cut it and see what happened. Now when we open this up, we can see that the Faraday fabric on the inside has not been affected. That's because the outer layer is 100% waterproof, and it doesn't allow the Faraday fabric on the inside to receive the moisture from contact on the outside. So the only one that truly passes the dunk test here with full water immersion, which is meant to replicate water exposure or contaminants exposure over time, months or years, the only one that truly passes that is going to be the Generation Faraday bag. This is the MaxLock Pro V2. And that concludes our school Faraday bag moisture and contaminant dunk test. Okay, so you can see that the TPU on the Generation Faraday MaxLock V2 outperformed the other foam, nylon, and fabric exteriors. Once water reaches the Faraday lining, the signal blocking integrity of the bag is compromised. A waterproof exterior prevents that failure chain. Durability doesn't stop at the material alone. With each use of the bag, the lock is also opened and closed again and again. The two bags here that have a lock are the CellLocked and the Generation Faraday MaxLock bag. The CellLocked bag is an example of a lock that relies on a thin metal pin. Over time, with normal use, those pins can become bent and/or broken. When that happens, the bag is rendered useless. The generation Faraday lock takes a different approach. With this fully metal lock, there's no vulnerable pin, and repeated opening and closing, as well as intentional mishandling, the metal holds its shape to maintain security. Okay, so when we look at all the results together, the conclusion is clear. Signal blocking is not a one-time event. It's a condition that has to be maintained day after day, month after month, year after year. In this testing, Generation Faraday's bag maintained that condition 20 to 40 times longer than other products. For schools, reliability isn't about having a product that works. It's about knowing it will still work after weeks of use, months of handling, and years of real-world wear. 100 or 200 cycle counts versus 3,000 or 4,000 is a stark difference. This may mean the difference between a few months of use before breakdown versus years. The comparison isn't only about which bag blocks signals. It's about which one keeps blocking them when it actually matters.